Hello everyone, my name is Derek and I am from Irvington High School in Fremont, California. So this is the project for my program, which is the ball tracking robot. And this is my third and final milestone, which involves completing the robot itself. This first involves mechanical assembly of the robot, which included installation of new modules such as ultrasonic sensor, the, um, the motor drive board, the L298N, and the two DC motors that drive the wheels, which are the most important things. Right now, I will give you an overview of how the robot works. So the distance sensor basically uses ultrasound pulses to figure out the distance between the robot and anything that's in the front of it. So if the distance is too large, then the robot will have to move forward to catch up to the ball. The camera, using the color masking technique that I described in milestone 2, along with a newly implemented technique, this milestone, which will determine whether the robot will turn left, right, or forward, given the x value of the center of the rectangle. So the rectangle is a contour. It is a contour of the largest mask inside the frame, inside the masking frame. And the x value of the center of the rectangle will determine whether the robot needs to go left, right, or forward. So I did this by setting if-else statements by using the middle of the frame, which is 320 pixels, and adding a buffer to it. So if the center is within the buffer, then the robot will go forward. If it's off to the buffer to the left, then it will go left, and correspondingly to the right. Right. So now I'll demonstrate. If it's to the left, the robot will go to the left. And if it's to the right, the robot will go to the right. Otherwise, it will go forward. It will go forward. And if the robot cannot see the ball, I also implemented something to help the robot find it. The robot will continue turning on its own until it locates the ball, in which case it will head for it. So this is basically how my project works. And there are details specific in the code that I have below in my portfolio, which I will add comments to describe further in detail later. You can take a look at that also. Right now, in essence, all I did was I made a principal main while loop that will always keep running until the program is terminated with CTRL-C. And this while loop will contain everything from color detection, a function color detection, to the function that moves the motors, and to the function that controls the distance sensor. So the biggest challenge that I faced while conducting this project was the malfunctioning of the two motors. So due to various reasons, most notably, at first, my ineptitude at coding them, and second, the inability for them to cooperate to full capacity themselves, the motors were essentially uneven. The left motor would always be weaker than the right one. And even though I fixed this later in code by using a PWM and the two enable pins on the L298N motor drive board to control the speed of each motor, this was still not fully resolved. And I will have to find a resolution for this in the modifications. However, as of now, it works pretty well. However, I need to find a more solid solution for this later. Right now, I am compensating for the weakness of the left motor by providing it with more power and weakening the right motor. However, I hope this is not the case in the future. I solved this issue by, as said before, evening out the strength between them, or the voltage between them. Another challenge that I faced was more of a primitive one. And this one was getting the ultrasonic sensor test code to work. When I first received my ultrasonic sensor, I was very stubborn, and I wanted to conduct the testing code all by myself. And after a long, brutal struggle with the ultrasonic sensor and a bunch of debugging, whether it be asking Google or asking GPT, eventually I realized the hard way, the very, very hard way, that the ultrasonic sensor detects the distance by itself instead of needing an actual function for it. And through this, I learned that sometimes the most straightforward solution is probably the best solution. And sometimes things are more simpler than you might think they are, which was in the case many times during this project, including my first and second milestone, which I have described in full detail in those two videos below. My next modification, which after this final milestone, will become a claw, or rather two claws that will grab the ball and pick it up once the robot parks in front of it, once the ball is within reach. Two pincers will lift the ball up using servos and hold it up and wait for the user to retrieve. Thank you for listening, and this is my file milestone.